Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Shafiq bin Sham. My matrix number is DD2032. Today I'm going to explain about our group project, which is micro alloy steel crankshaft for car engine. We are from group 5, manufacturing technology. For the introduction, a crankshaft is a necessary component of any internal combustion engine. It is a rotating shaft that converts the motion of a linear piston into rotation. It is made of crankshaft webs, connecting rod, and main bearing journal. It must be able to endure the high heat and pressure that combustion produces. The crankshaft is a complex component that requires precise machining and careful construction. For this project, we use microalloy steel to manufacture the crankshaft. Microalloy steel is a type of steel alloy with minor amount of alloying element. This alloying element is to increase its hardness, strength, formability, and weldability. To generate microalloy steel, the alloying elements are diluted with the base steel. The steel and alloying components are mixed and applied as a powder. The steel is shaped into the desired shape after being heated and warmed. Next, the literature review. Microalloy steel crankshafts are used in ordinary transportation as well as high-performance engine. Forging produces a more intricate structure with improved strength and fatigue properties. The finished item is then manufactured using machining to make it with exact form and dimension. For many years, the production of crankshaft for microalloy steel has been the subject of much research. In this past, microalloy steel were used to boost the strength and ductility of crankshaft. Utilizing microalloy steel crankshaft has several advantages. They have excellent strength to weight ratio, outstanding fatigue resistance, and portable. The design requirement of a crankshaft is main shaft, crank pin, connecting rods, and also counterweights. The dimension and material requirement of a crankshaft is the power output. It is influenced by material use, the shape of the crank throw, the length of the crank arm, number of crank pins, size of the main journal, and the number of counterweights. Next, operating temperature. It is designed the crankshaft to withstand a higher temperature because it is put in a combustion chamber. Next is the space constraint. Physical limitation of the space available for the crankshaft components while building a crankshaft.
Assalamualaikum, my name is MOHAMAD bin ZAINUL and I will be continuing on methodology part where I will be discussing about manufacturing process of crankshaft. The goal for this chapter is to assess the industrial crankshaft production process. Typically, three processes are used to make crankshaft, which are casting, forging, and machining. From these processes, we will be using three different kind of methods production to have three different kind of outcome, which are mass production, homemade production, and limited edition production. For mass production, we will be using a specific die mold manufacturing process because it is one of the tools necessary for modern industries to run mass production. Next is sand casting, which was chosen for homemade production because it is ideal for almost any complex part and almost every modern technology benefits from this manufacturing process. And lastly, 5-axis CNC machine was chosen for limited edition production because it provides efficient, expedient, and precise manufacturing capability. Each of these three manufacturing techniques has their own benefits, but also drawbacks that we will be discussed throughout this slide. Before we get into the details, let us know the meaning behind forging, 5-axis machining, and sand casting. Forging is the repeated deformation of heated solid metal to refine the grain structure and improve part strength without adversely affecting the material's ductility. The strongest metals currently utilized in industry come from forging. Both low and high volume spark production use forging. In forging, a hot chunk of rolled steel is placed between heavy dies having the pattern of a crankshaft. Under extreme pressure supplied by a forging press, the metal is squeezed into the crank basic shape and the metal is shaped via plastic deformation during forging. There are some steps we must follow to forge a metal, which are mold making, material selection, heating, which are for heating the metal, and next is forging, trimming and shot blasting after we forge the metal, and next is heat treatment to increase the strength, and lastly is inspection. Next is 5-axis CNC machine. CNC stands for Computer Numerical Control, and in machining, it denotes computerized control over the movement of the cutting tool. The term axis describes the cutting tool's freedom of motion, or more specifically, the direction in which it can move. As a result, in 5-axis machining, 5 separate axes each have the capabilities of the machine. The machine's cutting tool has 5 separate degrees of freedom, enabling it to produce extremely complicated geometry. So for the steps for this type of method, you can start with starting the program, loading the tools, mount remove part into the vise, setting tool length, and set part offset, and then load the C program, and then we can run the program and adjust offset as needed, and lastly we will shut down the program. Lastly is sand casting. Casting is essentially the process of pouring molten metal to create the desired result. Metal is put into the mold after being heated to the proper temperature. After knockout finishing, machining is used. Casting crankshafts have the lowest strength and are frequently fragile, therefore it can be enhanced through a few surface and heat treatment processes. So for the steps for sand casting, we will start with creating a mold and clamping the mold together so it won't move. Then we can start pouring the molten metal into the mold. After some time, it will start to cool down and we can remove the hardening steel to trim and finishing process.
My name is MOHAMAD FARHAN by SHAMRAN. As for chapter 4, for application, forging, crankshaft come in a unique shape due to specific type of machine that is used crankshaft for that. In this project, the crankshaft is used in the car. Hence, forging using a specific die mold of crankshaft is needed in order to mass product the item. For 5 and 6 CNC machines, it is a type of machining device used in industrial and commercial application. This type of machine can produce highly precise parts through its ability to move in 5 different axes simultaneously. This makes it a valuable tool to producing complex parts with intricate details. Due to its high level of precision and flexibility, the machines are used in a wide variety of industries, especially in the automotive industry. As for sand casting, it is typically used to create complex shape components that require higher tolerance and not limited by size. Sand casting also has a simple production process where the sand is put into a mold. Then a pattern is put into the sand and to take shape of the pattern. Then it is closed with another mold and filled with sand with shape as well. Then a hole is made to pour any molten metal used in the mold. For practically, press forging use a slow continuous pressure or force instead of the impact used in drop hammer forging. The slower ram level means the deformation reaches deeper, so that the entire volume of the metal is uniformly affected. By controlling the compression rate in the press forging, the internal strain can also be controlled. For 5-axis CNC machine, it has become increasingly popular in the production special edition product because the machine offers a level of precision and accuracy that is simply not achievable with traditional manufacturing methods. The main advantage of 5-axis CNC machine is the ability to produce complex shape and intricate details. This is because the machine can move in 5 different directions, allowing for a greater degree of control over the production process, which is essential for special edition products. For sand casting, it is a process that has been used for centuries to produce metal parts with intricate shape and details. These castings are made using sand mold formed from the wet sand, which is contain water and organic bonding compound typically referred as clay. There are 2 types of molding sand, which are natural bonded bed sand and synthetic flake sand. There is typically no mold release agent, and the mold is generally destroyed in the removal process. For economical, for the forging start with a material heated until it becomes soft. Then the material is pressed by a press machine until the desired shape, which is crankshaft, is visible. The press machine comes in a different type of presses such as mechanical press, hydraulic press, and screw press. The cost of press forging machine is also affected by the time that it takes to produce a part. For 5-axis CNC machine, it requires 5 different axes of movement in order to accurately move the cutting tool around the material. Each axis must be precisely calibrated and the cutting tool must be programmed to move along the 5 required axes. Every axis must be programmed separately, which is require a skilled operator and a great deal of time. For sand casting, incorporate pattern and sand in a gating system. After removing the pattern, fill the mold cavity with molten metal and allow the metal to cool. This process is economical because it eliminates the need for machining and associated costs. The precision and accuracy of the sand casting process make it ideal for the crankshaft production. Sand casting is also a great choice for crankshaft production when it comes to the most economic for mass production process. For social, specific MOHD provide special benefit in creating specific part for vehicle application, allowing to produce parts that better help people with spare part for cars. It can be used to create car parts that is benefit local industry. With additive manufacturing, forging can also create jobs in the local industries, providing economic stability in areas that need it the most, and it need more hand working and comes with different shapes and sizes. For 5-axis CNC machine, it also helps to reduce unemployment and create economic growth. The technology has also opened new career paths for individuals with the necessary skill and knowledge to operate the machines. This has provided for more job security and stability for those in the field. The machines are designed to reduce the risk of accident in the workplace by reducing human error. For sand casting, it also provides social sustainability benefit. In many cases, sand casting is used to create spare parts for vehicle application, allowing to produce parts that better help people with spare parts for cars. It can revitalize community as it can be used to create machinery and equipment that benefit local workshop. Sand casting can also create jobs in local industry, providing economic stability in areas that need it the most, as it need more hand working. For environmental, forging is also environmentally friendly where the press itself is recyclable. The press can be used multiple times without any problem and can withstand high temperature. This makes the press can be used in maximum number and help in decreasing disposable waste. For 5-axis CNC machine, it can produce small and precise parts that require far less material than traditional manufacturing methods. This means that less material needed to be mined, processed, and transported in order to create the parts. It also can produce with higher accuracy and faster speed, which can reduce the amount of energy used in production. It can result in fewer emissions released into the atmosphere. The precision of this part can reduce the amount of waste created in production, which in turn reduce the amount of waste that is sent to landfills or incinerators. For sand casting, it is environmentally friendly. It's an essentially circular production where 99% of the material can be recycled. For example, the aluminium is extremely recyclable, important for environmental concern and also for whole life cost analysis. I think that's all for chapter 4. We proceed to the next chapter.
For the conclusion, overall, the goals of this project have been met, if not beyond, with tremendous success. This project is a great illustration of how to properly plan and carry out a project. The first manufacturing process we use is forging. A crankshaft is a challenging process, but one of the most reliable and cost-effective way to produce a high-quality crankshaft. The next manufacturing process is the 5-axis CNC machining. This process provides a reliable and effective way to produce a high-quality crankshaft with a special addition of dimension. This technique is affordable and may be applied to produce a broad variety of crankshaft design. Lastly is the sand casting. This process produces a crankshaft with a successful and cost-effective process. This method has been successfully applied for many years ago to produce a crankshaft of the highest caliber due to the wide variety of design options offered by the sand casting process. That's all from us. Thank you.